Today we're going to be solving quadratics by factoring. So the first thing that we have to ask ourselves is the question, if the product of two numbers is 0, what do you know about one or both of the numbers? So for example, if I take 2 times x and I make it equal to 0, what do you know about x? Well, it means that x has to equal 0. So if we have two numbers where the product of them is 0, then we know 1 or both must equal 0. Okay, one or both of those numbers must equal 0. This is what we call the zero product property. Okay, you're taking the product of two numbers and then they equal 0. So one of them has to equal 0. All right, so let's look at solving some equations using the zero product property. If we know that the quantity x plus 3 times the quantity 2x minus 5 is equal to 0, that means that either x plus 3 has to equal 0 or 2x minus 5 equals 0. So then what we're going to do is just solve each of these to figure out what x equals. So here we would subtract 3 on both sides, and x would equal -3. So that's one answer to this. The other situation we're in, we have to add 5. So then we would have 2x equals 5 divided by 2, and x would equal 5/2. You can leave it as a fraction like that. You can write it as a decimal of 2.5. It doesn't matter. But since there were two factors here, that's going to produce two different answers. Okay? So then what if we have the quantity 3x plus 1 times the quantity 4x minus 7 equals 0? Again, we have the product of two things. It's equal to 0, which means either 3x plus 1 equals 0 or 4x minus 7 equals 0. Now, some of you may be able to understand how to solve this without showing the steps of work. And if you can, great. If not, then you're going to show your steps of what you're doing. So if we have this, we're going to subtract 1 on both sides, get 3x equals -1. Then we would divide by 3, and x would equal -1/3. Here we have 4x minus 7 equals 0, so we would add 7. 4x would equal 7. Dividing by 4, x equals 7/4. Again, you can leave them as these, or you can write them as decimals. It's best to keep them in fraction form, but it doesn't matter. Something that we didn't talk about with either of these examples yet, but that you can do very simply by just using the calculator or plugging this in, is checking to make sure that they work. So if we take -1/3 and plug it in for x, 3 times -1/3 is -1. -1 plus 1 is 0. Well, 0 times whatever this is going to give me 0, so that's fine. Similarly, it would work if we have 7/4. So it doesn't matter what this one is. If we plug 7/4 in here, 4 times 7/4 is 7. 7 minus 7 is 0. So it checks. Okay? So that's what happens if they're already factored for us. But what happens if they're not? Okay? So if we have an equation that looks like this, for example, 3x squared plus 9x equals 14 plus 14 equals 0, what do we do with that? So this is where we're going to actually be doing the whole solving by factoring. Those other ones were already factored for us. Now we have to do the steps to get them factored first. So we need to make sure that the equation is equal to 0, or else we can't factor it. We're going to factor it completely for the second step, including the GCF. And then it looks exactly the same that we just did. So we're going to set each parenthesis equal to 0. We're going to solve for that variable, whatever it is, and then we're going to check our solutions, whether that means that we're physically writing something down to check them, or we're just plugging it back into the calculator. Okay? So for this, x squared plus 9x plus 14 equals 0, we're going to use guess and check for factoring here. The first two terms need to multiply to give us x squared, so that's going to give us x and x. We know that these both need to be positive. And the back two spaces have to multiply to give us 14, and those same numbers need to add to give us 9. So that's going to be 2 and 7. Now that we have it factored, we know that x plus 2 has to equal 0, or x plus 7 equals 0 using the zero product property. So these ones are ones that are pretty easy that you wouldn't necessarily have to show your work of how you're solving them. If we have x plus 2 equals 0, we're going to subtract 2 from both sides and get -2. And if we have x plus 7 equals 0, we're going to subtract 7 on both sides and get x equals negative 7. Okay, now the checking process, again, you can choose to plug into the calculator. In case we factor this wrong, we don't necessarily want to check here. We're going to go back to the original question. So I'm going to check negative 2 here. And that just means that I'm going to plug negative 2 in for all of those x's. So this would give us 4 minus 18 plus 14, which would give us 0. So it checks, all right? And you can do the same thing for negative 7. All right, so let's take a look here at our next one. We have x squared minus 56 equals negative x. Is this in the proper form for us to factor yet? No, we've got to make it equal 0. So we do want it in standard form, meaning the x squared term would come first. What do we have to do with this negative x to move it over? We would have to add it, and then we would have our negative 56. None of those are like terms to combine. If they were like terms, then you would combine them. All right, so then we're going to factor the first two spaces need to be x and x to give us x squared. Since it's plus minus, we do need one of each sign. And our two numbers need to multiply to give us negative 56 and add to give us a positive 1. So we're going to use 8 and negative 7. Again, now that we have them equal to 0, multiply the product of two things equal to 0. We're going to set each piece equal to 0 and solve. So here we would get negative 8, and here we would get positive 7. Okay? When you're doing your checking, you're going to want to go back to the very original question. Okay, so I'm going to actually practice plugging in this negative one. You could do either one, and actually you would need to check both of them. So for checking, we would have negative 8 squared minus 56 equals a negative 8. Okay, that negative has nothing to do with the negative that we got with that number. So let's see if this works. So we have 64 minus 56. A negative 8 would actually be a positive 8. So 64 minus 56 is 8, so it does check. So both of those are good to go. Well, you would have to plug this in to actually make sure, but it does work. Okay. All right, let's look at here. We have 2x squared minus x minus 3 equals 0. This one is equal to 0, so we're ready to factor. Since the first space is 2x squared, we need 2x and x. Since it's minus minus, we do need one of each, and we're not exactly sure yet where that needs to be, but they need to, like when we multiply them together, give us a negative 1 there. So that means that we need 2x minus 3 and x plus 1. And just like we've done in the past, you can multiply these together really quick to make sure that it gives you the original question too. So 2x squared plus 2x minus 3x would give us negative 1x and then minus 3. So this is where your factoring is going to be important. You have to know how to factor these in order to actually be able to solve by factoring. All right, so if we set this one equal to 0, we would add 3 and divide by 2. So x equals 3 halves. So you notice I didn't show all of my steps to do that, and that's okay. If it confuses you to do that, then write out the steps. And then x plus 1 equals 0 means we would subtract the 1 and get x equals negative 1. So again, if you take these and plug them back in, they both will work. Okay. So let's keep moving on, looking at different situations. So here's our next one. We have 2x squared plus 6x equals negative 4. So is it ready to go? No, it is not equal to 0. So we need to move that negative 4 over by adding it. And it is not like terms with anything. So we do have our 3 terms still here. So the first thing we do with factoring is we look for a GCF. So all of these do have a 2 in common. Left-hand side would be x squared plus 3x plus 2. And then we're going to see if that inside piece can factor. So that GCF of 2 isn't going anywhere. Our first two spaces need to be x and x to give us x squared. We do need a plus and a plus. The back two spaces need to multiply to give us 2, so the only way to do that is 1 and 2, and those would give us 3x. So we know we're good. Now, if we go to set each of these pieces equal to 0, does 2 equal 0? No. Is there any variable to solve there? No. So in this case, that is not going to produce an answer for us, but we still set it equal to 0. All right, here we would get x equals -1, and here we would get x equals a -2. Okay, and there are your answers. And it's worth saying, I probably should have said this earlier, since it's a quadratic and x squared, that means that you're going to have 2 answers for these questions. Okay? All right, next one, we have x squared minus 3 equals 13. We're going to solve this question. All right, so we're going to move the 13 over. Now the 13 is like terms with this -3. So when we subtract 13, we would get x squared minus 16 equals 0. So we know that that's a difference of squares. So we're going to have x and x. To get 16, we're going to use 4 and 4. And we need one positive and one negative so that those middle terms cancel out. Then we're setting them equal to 0. Whoops. Sorry, I just switched the order of those, but that's okay. We're still setting both of them equal to 0, so we would get x equals -4 and x equals +4. You could also write this as x equals plus or minus 4 since you have both a positive and negative. It doesn't matter though. So just a quick side note here though. This question we could actually solve a different way. Yeah, you could factor it, but what do you notice here? You notice that it doesn't have that x term, the linear term, like all of our other ones did. So we can actually solve this by what we call square roots. So we could add the 3 over to get the x squared by itself. And then we would take the square root on both sides. But we have to remember positive or negative, because positive 4 squared is 16 and negative 4 squared is also 16. So you have to be very careful. You're still going to get the same answer. So this was square roots. And you're more than welcome to use that method. That only works if there is no linear term. Okay? All right, last example here. What happens if we have x squared minus 4x equals 0? So this one looks a little different than the other ones as well. But here, this is missing the constant term. It doesn't have that just number, okay? So our first step in all of these, remember, is still look for a GCF. X squared minus 4x, they have an x in common. Left-hand side is x minus 4. So we still have 2 things multiplied to equal 0. That means we're going to set them both equal to 0 and solve. Well, this GCF, set it equal to 0, x equals 0. That gives us an answer. There's nothing else to solve for, so that is one of our answers. Over here, we would add 4 and get x equals 4. There are your 2 answers, okay? So in general, there are 3 different situations that we're in and things that we want to look for, okay? So the first one is that there is no x term. That's where you're going to solve by square roots. You're going to get the x squared term by itself, take the square root on both sides, and then not forget, you don't want to forget the plus or minus sign. Now, keep in mind with this only works if there's no x term. If you don't want to remember that process, then you can still solve by factoring for these types of questions. It should still factor. If there is a linear term, meaning you have all 3 terms, you have an x squared, an x, and a constant, that's where you're going to do our normal process. You're going to set it equal to 0, factor it completely, including the GCF, set those parentheses equal to 0, and solve. And the last situation is if you have no constant term, that was like example 8 that we just did, you're going to factor completely, including the GCF. You're going to set each factor equal to 0 and solve them. And that's it.